Welcome to SS2 Further Mathematics, Term 3, Week 5. In standard differentiation, y is expressed explicitly as a function of x, y equals f(x). But many curves and relationships are not so conveniently expressed, either they are given implicitly, as equations involving both x and y, or parametrically, both x and y expressed in terms of a third variable t. By the end of this lesson, you will differentiate implicit equations, find gradients on implicitly defined curves, differentiate parametric equations, and solve WAEC further mathematics problems on both types. Let us begin. An implicit equation is one where y and x appear mixed together, such as x superscript 2 plus y superscript 2 equals 25, a circle, or x superscript 2 plus xy plus y superscript 2 equals 7. We cannot always solve for y explicitly, or it is inconvenient to do so. Implicit differentiation: differentiate both sides of the equation with respect to x, treating y as a function of x and using the chain rule for any term involving y, chain rule for terms in y, d/dx equals f, y, times dy/dx. Key examples: d/dx equals 2y times dy/dx. d/dx equals 3y superscript 2 times dy/dx. d/dx equals cos y times dy/dx. d/dx equals e to the power of y times dy/dx. d/dx equals x times dy/dx plus y times 1 equals x dy/dx plus y. Product rule. Method: differentiate implicitly. Collect all terms containing dy/dx on one side, factorize and divide to find dy/dx. Worked example 1, find dy/dx for x superscript 2 plus y superscript 2 equals 25. Differentiate with respect to x, 2x plus 2y dy/dx equals 0. 2y dy/dx equals -2x. dy/dx equals x/y. This gives the gradient at any point, x, y, on the circle. Note that the gradient is expressed in terms of both x and y, not just x. At point 3, for dy/dx equals -3/4. At 4, -3 dy/dx equals -4/3 equals 4/3. Worked example 2. Find dy/dx for x superscript 2 plus xy plus y superscript 2 equals 7. Differentiate 2x plus x dy/dx plus y plus 2y dy/dx equals 0. Product rule on xy. 2x plus y plus x plus 2y dy/dx equals 0. x plus 2y dy/dx equals -2x plus y. dy/dx equals -2x plus y /x plus 2y. Once dy/dx is found implicitly, we can find equations of tangents and normals at specific points. Tangent at point x0, y0 gradient m equals dy/dx evaluated at x0, y0, equation, y0 equals m x, x0. Normal at x0, y0 gradient equals -1/m, perpendicular, equation, y0 equals -1/m x, x0. Worked example 3, find the equation of the tangent to the curve x superscript 2 plus 2xy, y superscript 2 equals 1 at the point 1, 2. Differentiate 2x plus 2, x dy/dx plus y, 2y dy/dx equals 0. 2x plus 2x dy/dx plus 2y, 2y dy/dx equals 0. 2x, 2y, dy/dx equals -2x, 2y. dy/dx equals -2x plus 2y, /2x, 2y equals -x plus y, /x, y. At 1, 2 dy/dx equals -1 plus 2, /1 to 2 equals -3/-1 equals 3. Tangent, y, 2 equals 3x, 1, y equals 3x, 1. Worked example 4, a second derivative, find the superscript 2y slash dx superscript 2 for x superscript 2 plus y superscript 2 equals a superscript 2. From example 1, dy slash dx equals x slash y. Differentiate again with respect to x. The superscript 2y slash dx superscript 2 equals d slash dx, x slash y equals dash, y times 1, x times dy slash dx, slash y superscript 2 equals dash, y, x slash y superscript 2 equals dash, y plus x superscript 2 slash y superscript 2 equals dash, y superscript 2 plus x superscript 2, slash y superscript 3 equals a superscript 2 slash y superscript 3, using x superscript 2 plus y superscript 2 equals a superscript 2. Parametric equations express x and y separately in terms of a parameter t. X equals xt, y equals yt. The curve is traced out as t varies. Chain rule for parametric differentiation: dy slash dx equals dy slash dt divided by dx slash dt equals dy slash dt forward slash dx slash dt. Second derivative: d superscript 2y slash dx superscript 2 equals d slash dx, dy slash dx equals d slash dt, dy slash dx divided by dx slash dt. Worked example 5, a curve is given parametrically by x equals t superscript 2 plus 1, y equals 2t, 1. Find dy slash dx and d superscript 2y slash dx superscript 2 and the equation of the tangent at t equals 2, dx slash dt equals 2t, dy slash dt equals 2, dy slash dx equals dy slash dt forward slash dx slash dt equals 2 slash 2t equals 1 slash t. At t equals 2, dy slash dx equals 1/2. Point x equals 4 plus 1 is equal to 5, y equals 4 minus 1 is equal to 3. Tangent, y, 3 equals 1/2 x, 5, y equals x slash 2 plus 1/2. Second derivative, d slash dt, dy slash dx equals d slash dt, 1 slash t equals dash 1 slash t superscript 2. d superscript 2 y slash dx superscript 2 equals dash 1 slash t superscript 2 forward slash 2t equals dash 1 slash 2t superscript 3. At t equals 2, d superscript 2 y slash dx superscript 2 equals minus 1/16, negative. The curve is concave downward at this point. Worked example 6, second parametrically x equals a cosine t, y equals a sine t, dx slash dt equals a sine t, dy slash dt equals a cosine t, dy slash dx equals a cosine t forward slash a sine t equals cosine t slash sine t equals cot t. At t equals pi slash 4, point, a slash square root 2, a slash square root 2, dy slash dx equals cosine, pi slash 4, slash sine, pi slash 4, equals minus 1. The gradient is minus 1 at this point, consistent with the implicit result for x equals y, slope equals x slash y equals minus 1 when x equals y. Common WAEC further mathematics questions on implicit and parametric differentiation, given x superscript 2 plus y superscript 2 plus x plus by equals c, find dy slash dx, use it to find the gradient at a given point, find the equation of the tangent or normal. Given x equals f t, y equals g t, find dy slash dx as a function of t, evaluate at a specific value of t, find the Cartesian equation by eliminating t. Common parametric curves, parabola x equals at superscript 2, y equals 2 at a greater than 0, the curve y superscript 2 equals 4x. dy slash dx equals 2a slash 2 at equals 1 slash t, tangent at point, at superscript 2, 2 at y, 2 at equals 1 slash t, x, at superscript 2, t equals x plus at superscript 2. Circle x equals a cosine t, y equals a sine t, as above. Ellipse x equals a cosine t, y equals b sine t, dy slash dx equals b cosine t, forward slash a sine t equals dash b slash a cot t, cycloid x equals a t, sine t, y equals a 1, cosine t, the path traced by a point on a rolling circle. dy/dx equals sin t/1 cosine t. Key skill for WAEC, eliminating the parameter t to find the Cartesian equation. Example: x equals t superscript 2, y equals 2t, t equals y/2, x equals y/2, superscript 2 equals y superscript 2/4, y superscript 2 equals 4x, parabola. Example: x equals 3 cosine t, y equals 3 sin t, x/3 equals cosine t, y/3 equals sin t, x/3, superscript 2 plus y/3, superscript 2 equals 1, x superscript 2 plus y superscript 2 equals 9, at circle, radius 3. Key points: implicit differentiation, differentiate both sides of equation with respect to x, use chain rule on y terms, d/dx equals f, y, dy/dx, use product rule on mixed terms like xy, solve for dy/dx by collecting terms. Key: d/dx equals 2y dy/dx, d/dx equals x dy/dx plus y, parametric differentiation, dy/dx equals dy/dt, /dx/dt, d superscript 2 y/dx superscript 2 equals /dx/dt. Tangent at x0, y0 y0 equals m, x, x0, where m equals dy/dx at the point. Normal, gradient equals -1/m. Important parametric curves, circle, are cosine t, are sin t, parabola, at superscript 2, 2 at. Eliminating parameter, use substitution to get Cartesian equation. WAEC test, find dy/dx and evaluate at a point, find tangent equation, find the superscript 2 y/dx superscript 2 for implicit or parametric curves.